In the country of United States of Heightlandia, the height measurements of 10-year-old children are approximately normally distributed with a mean of 56.7 inches and a standard deviation of 3.2 inches. What is the probability that a randomly chosen child has a height of less than 58.3 inches? All right, so the question here is for a probability. All right, so we want the probability that a child has a height less than 58.3 inches. And what's nice is, even though we have a lot of techniques that are required for solving probability problems, we're told that our data is normally distributed. I meant to get a highlighter there, not mark it out. And because our data is normally distributed, it's a great idea to start this problem out by drawing a bell curve, because it can make a nice visual cue for all the pertinent information. So we have a mean of 56.7 inches and a standard deviation of 3.2 inches. So the mean, 56.7. And we're looking for the probability that a child has a height that's less than 58.3 inches. So I'm just putting this somewhere to the right. But if it's less than 58.3, then I need to shade to the left. So the calculator function that will come up with the value of areas under a normal curve is normal CDF. It takes 4 inputs. The first two are the lower bound of your shaded region, which in this case is negative infinity, so I'll use negative e to the 99 for just something that's really small. The upper bound, which is 58.3. The mean, 56.7, and the standard deviation of 3.2. Now this is very nice, giving it the 4 different values, because otherwise you'd have to calculate z-scores for at least the 58.3. And that z-score is probably going to then need to be rounded off to a certain number of decimals, which can affect the accuracy of your final answer. In this case, the calculator makes sure you're using the most decimals to get the best approximation you can. So we'll use the calculator and the normal CDF function. So when I call up normal CDF, it takes 4 inputs. The first is, of course, this negative infinity, so I'm going to do negative second e 99, so the comma there gives me the e, I'm sorry, comma 58.3, 56.7, and 3.2. So all those values separated by commas, and you get 0.6915. Okay. Now, some of you may have seen a menu show up whenever you did the normal CDF function, and that's okay. It's just a different mode setting in the calculator, and you just enter your 4 values into this, and then it will take those values and put them into normal CDF for you. So you would still do negative e to the 99th, 58.3 is the upper limit, the mean is 56.7, the standard deviation is 3.2. So the idea is the calculator is just helping you know what the inputs are to the function. All right, the next part says, what's the probability that a randomly chosen child has a height more than 55.8 inches? So for more than 55.8, then what we would do is draw our distribution again. 55.8 is somewhere lower than the mean. And we're shading to the right because this is more than. So we would do normal CDF. The lower bound of this shaded region is 55.8. The upper bound is positive infinity, so positive e to the 99th, and still the same mean and standard deviation. So we'll use the calculator to come up with that value. 55.8, whoops, second comma gives me the e, and then 99, 56.7, and 3.2. Press enter again, and it will calculate that function value for you, so 0.6107.